And today I want to give you one more stoichiometry problem for you to master this standard. We are dealing with a reaction that has a reagent that comes in the form of dissolution, but the most important thing that I want to give you is that this reaction has yield. Not only direct yield, which means they are giving us an amount of reagent in order to calculate the amount of product, but also inverse yield, that is, we are given an amount of product obtained in order to calculate the amount of reagent. As you can see from our thermometer, this is a typical exam exercise, so if you understand every procedures we are doing, you will be ready to pass your exam.
Binnacle project.
As always, let's read together the statement. It says that hydrochloric acid reacts with aluminum hydroxide to produce aluminum chloride and water. This is the reaction. Section A. Starting with 300 milliliters of an hydrochloric acid solution with a density of 1.35 grams per cubic centimeter and 25% purity mass, calculate the grams of aluminum chloride obtained if the reaction has an 85% yield. And section B. If 250 cubic centimeters of water has been obtained, find the milliliters of hydrochloric acid that were used. So, the first thing we're going to do is to write the equation. Hydrochloric acid, this is hydrochloric acid, is reacting with aluminum hydroxide. This is aluminum hydroxide. In order to produce aluminum chloride, this is aluminum chloride, and water. And I'm not reading anymore, just I'm going to balance the equation. Now I want you to stop the video and try to balance the equation by eye, but as exists the possibility that you can't do it this way, let me do it mathematically. Look, it's very easy, so don't be scared. The first thing we're gonna do is to place these letters here, these variables here, that will help us to balance the equation. And how many hydrogen atoms do we find on the left side? Well, here we have A times 1, A, plus 3 times 1 is 3, but also multiplying B, 3B, 3B, that's it. That must be equal to the hydrogen atoms on the right side, 2D. Now, let's balance chlorine atoms. A times 1 is A. That must be equal to C times 3, 3C. Now it's turn for aluminum atoms. B times 1, please don't get confused with this little number. Aluminum is B times 1, B. That must be equal to C times 1, C. Now it's turn for oxygens. Here again, 3 times 1 is 3, but 3 multiplying B, 3B. That must be equal to D. And now we have 4 letters and 4 equations, and what we are doing is to choose one of the simplest equations in order to rewrite the other ones. Let me use this one, which means that whenever I find letter B, I will write C, that is A plus 3C must be equal to 2D. Easy, right? A equals 3C. And finally, 3C must be equal to D. Okay? And now, let's do it again. For example, let's choose the second equation, and whenever I find letter A, I will write 3C. 3C plus 3C equals to D. And the other one, 3C equals D. And now, let's clean the first equation. 3C plus 3C is 6C, must be equal to 2D. And let's divide both sides by 2. 6 divided by 2 is 3c equals d. And it's the same as the second equation. So I'm using only one time, and this is the end of trip. Now we are giving values to c in order to write all the stoichiometric coefficients. Let's use the simplest value, that is c equals 1 and d equals 3 times 1, 3. And here we have a equals 3 times c. 3 times 1 is 3 also. And finally, b equals c. b equals 1. And here we have the stoichiometric coefficients. Easy, right? I've erased the previous calculations, but I've placed the stoichiometric coefficients on their correct places. 3, 1, 1, 3. And you can check that the equation is correctly balanced. And section A says, starting with 300 milliliters of an hydrochloric acid solution with a density of 1.35 and 25% purity mass. Let me try it for you. It says that the hydrochloric acid comes in the form of a dissolution. And they say that we have 300 milliliters of this dissolution. Here we can find hydrochloric acid, but also with water, and water. So our task is to know the grams or moles, it doesn't matter, the grams of hydrochloric acid that comes in this little glass. Not with the water molecules. This is an spectator molecule that would not run in our equation. We need the grams of hydrochloric acid. And they are giving us that this dissolution has a density of 1.35 grams per cubic centimeter. And they are also giving us the purity mass, which is 25%. So now it's time to use this data in order to calculate the grams of hydrochloric acid that comes in this little glass. Now, please follow me with this argument. Look, we're given the volume of all the dissolution and also the density. As you probably know, density equals mass of dissolution divided by volume of dissolution. So, using this data, we can calculate the mass of dissolution, okay? But don't forget that we are interested in knowing only the mass of hydrochloric acid that comes inside. How can we know it? Using the purity mass, because don't forget that purity mass equals a mass of hydrochloric acid, only hydrochloric acid, divided by mass of this solution. That's the way. Look, density equals mass of this solution divided by volume of this solution. So, using this formula, we are calculating the mass of all this dissolution, hydrochloric acid and water. 1.35 grams per cubic centimeter equals mass of the solution, let me say it's X, divided by volume of this solution. But it is very important for you to have a control of the units. If the density is given in grams per cubic centimeter, it is necessary to write the volume in cubic centimeters. And good news, because milliliter equals cubic centimeter, okay? Milliliter equals cubic centimeter. So there comes our 300 cubic centimeters. And now it's time to know the amount of mass of the solution. Let's do 1.35 multiplying 300, okay? And let's use the calculator in order to calculate this data. I hope you have obtained 405 grams of this solution, but don't forget that this is the mass of all this solution, and we are interested only knowing the amount of hydrochloric acid. And how are we going to know this data? Using the purity mass. As you probably know, purity mass equals mass of solute, that is only hydrochloric acid, divided by mass of this solution, and we have already obtained this data, but also multiplied by 100. And it's time to place properly our numbers. This is 25. Must be equal to the mass of hydrochloric acid, only hydrochloric acid, not with water, only hydrochloric acid, which is X, divided by mass of this solution, 405, also multiplied by 100. And there we have the value of grams of only hydrochloric acid. X must be equal to 25 multiplied by 405 and divided by 100. And let's use our calculator. 25 multiplying 405 and divided by 100. We have 101.25 grams of hydrochloric acid. Don't forget what we've done. We were interested in knowing only the grams of hydrochloric acid. We were given the volume of all this solution, but also the density. So using this data, we could calculate the mass of this solution. But how can we calculate only grams of hydrochloric acid, not water, because we don't need the grams of water that travels here. We only need the grams of hydrochloric acid. Well, using the purity mass. As you know, purity mass is mass of solute, hydrochloric acid, divided by mass of this solution, our 405. And thus, we could know that in this little glass travels 101.25 grams only of hydrochloric acid. That's it. I've erased the previous calculations, but I've placed here our result, 101.25 grams of hydrogen chloride. And section A says, calculate the grams of aluminum chloride, if our reaction has an 85% yield. 85% yield. This is the most important thing that I want to show you on this problem. And what are we going to do? The first thing we're going to do is to place properly our conversion factors in order to calculate the theoretical grams of aluminum chloride. Let's do it. 101.25 grams of hydrogen chloride. And as always, the first conversion factor helps us to move from grams of hydrogen chloride in order to move into moles of hydrogen chloride. With 1 mole will be enough to do this calculation. And now it's time to add the atomic masses of these atoms. 1 for hydrogen and 35.5 by chlorine. You can read this data in the statement. 1 plus 35.5 is 36.5 grams of hydrogen chloride is 1 mole of hydrogen chloride. Second conversion factor, it will help us to move from moles of hydrogen chloride to move into moles of aluminum chloride. And there comes the stoichiometric coefficients, 3 for the hydrogen chloride and 1 for the aluminum chloride. Okay? So that's why it's very important to balance properly the equation. And the third conversion factor will help us to move from moles of aluminum chloride and with only 1 mole we will build this conversion factor. And now it's time to add the atomic masses of these atoms. Aluminum, that is 27, plus 3 chlorine atoms, that is 3 multiplying 35.5. Let's use our calculator, and we have 27 plus 3 multiplying 35.5. 133.5 grams of aluminum chloride is 1 mole of aluminum chloride. Now let's use the calculator in order to know the theoretical grams of aluminum chloride that we would obtain. I hope you have obtained 123.44 theoretical grams of aluminum chloride. But what happens? That in reality we will always obtain less amount of this substance. And why is it so? That's because in reality nothing is ideal, and there are little masses of substances that don't react, etc. So how can we know the real amount of substance that we will obtain? Using this data, the yield. The yield, that is a percentage, is real mass divided by theoretical mass. Theoretical mass multiplied by 100. And here, using this formula, we will obtain the real mass of aluminum chloride that we will obtain. Let's do it. 85 equals X, the real mass of substance that we are obtaining, divided by 123.44 multiplied by 100. And here we have the real mass of aluminum chloride. X equals 85 multiplying 123.44, 85 multiplying 123.44 divided by 100, And let's use our calculator to know the real mass of aluminum that we are going to obtain. 85 multiplying 123.44 divided by 100. We will obtain 104.92 grams of aluminum chloride. And these are real grams of this substance. Okay? This is a very typical situation in which we are given the yield of a reaction. And look what we've done. First of all, we calculate the theoretical grams of the substance we are asked to calculate. And using this formula, the yield of a reaction, we can obtain the real grams of a substance. As I told you previously, this data is smaller than the theoretical one. And that's it.
Binnacle project.
And now it's time to solve section B, which says, if 250 cubic centimeters of water has been obtained, find the milliliters of hydrogen acid that were used, the milliliters of this dissolution that were used. And what are we going to do? The first thing we're going to do is to calculate the theoretical grams of hydrochloric acid that were used. Theoretical grams. The second thing we're going to do is to use properly the yield in order to calculate the real grams. And finally, we are using this data in order to calculate the milliliters used. Okay? That's the way. And now it's time to calculate the real grams of hydrochloric acid that were used. And do you think that using 506.44 grams of hydrochloric acid, we will obtain 250 grams of water? Our reaction is not perfect, so using this amount of hydrochloric acid, we would obtain a less quantity of water. So it is necessary to use more than these grams. Here you can find the two possible solutions. We are using the yield in one of these forms, multiplying or dividing? Which one do you think that will lead us to obtain more than 506? Well, the first one is not correct, as 506.44 multiplying 0.85 equals 430.47 grams, and this is not the correct solution. The way to obtain more than 506 is the second one. 506.44 divided by 0.85 equals 595.81 grams of hydrochloric acid were used. Real grams, and that's the way. I've erased the previous calculations, but I've placed here our result. Don't forget that we need 595.85 real grams of only hydrochloric acid. So now it's time to properly use this data in order to calculate the milliliters of the solution that we will need. As this data corresponds to mass of solute, why don't we use the purity mass in order to calculate the mass of all this dissolution? And once we have the mass of this solution, we can use the density in order to calculate the volume of it. Okay? So let's do it. As you know, purity mass equals grams of hydrochloric acid divided by grams of this solution, also multiplied by 100. And we are doing 25 must be equal to grams of hydrochloric acid, that is 595.81, divided by mass of this solution, all hourglass, also multiplied by 100. And now it's time to solve for x. X comes here, the 25 goes there, and we have x equals 595.81 divided by 25 and also multiplied by 100. And let's use our calculator because we are obtaining the mass of all this dissolution. 595.81 divided by 25, and it gives us 2,383.24 grams of this solution. Okay? And now, using this data with the density, we can know the volume of the solution that we will need to use. And here you have it. Density equals mass of this solution divided by volume of this solution. That is 1.35 grams per cubic centimeter must be equal to mass of the solution 2,383.24 grams divided by the volume of the solution. And now it's time to use our calculator to do 2,383.24 divided by 1.35, which means 1,765.36. This is volume, but it comes in cubic centimeters. Cubic centimeters of this solution. But as they are asking us to find the milliliters of the solution, good news, because cubic centimeters equals milliliters. So, as cubic centimeters equals milliliters, this is the solution of section B. And don't forget what we've done. We were given the amount of product in the form of these 250 cubic centimeters of water that we converted into grams of water. Then we injected properly our conversion factors in order to calculate the theoretical grams of hydrochloric acid, theoretical grams. And we divided this result by 0.85 in order to calculate real grams of hydrochloric acid, real grams. And finally, we used this data in order to calculate the volume, the milliliters of this solution that we need to use in order to have this amount of real grams of hydrochloric acid.
Binnacle project.
So, if you've understood every steps we've gone through in this problem, I think that you're already mastering stoichiometry. But don't forget that there is still a lot of things to do. So, see you next time. Bye bye! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!